Okay, so we'll have a little quiz on metabolism on Monday. Pretty easy.
I was going to say, somewhere in that stack there's a paper with an answer on it.
One with an answer on it. Okay. I've never seen my computer do that before. See that flashing thing? Am I doing something wrong? Yeah, I'll get it. Can everybody, actually, Ryan, can you turn a light or two off back there? Now, I have one more little treat for you guys. The little homework things you guys turned in. Would you just carry those to lab and we'll distribute them over there? There's really not any grading involved. I mean, I graded them, but most all of you got 10. Okay, now where's my clicker and I'll be ready to go. Almost. This is a picture of my daughter, as usual with these opening pictures. They're usually my kids. My daughter Jenna, the one who just got married a few weeks ago. Have you seen the video of me dancing with her at her wedding?
Just a photo.
You just showed a picture.
Okay. Anyway, it's in video also. Anyway, this is her right here in the front seat. This is her when she was a freshman at the University of Oregon. First term she was there, she went out for the rowing team, the crew team they call it, and she was in eight-man plus coxswain. That's what you call it when you have 8 rowers and one person who yells and tells you when to paddle up here. In a course of 2.5 months, she worked her way to the front seat. This is where you put the most powerful rower, is in the front seat, and sure enough, there she is. I was out there in the coach's boat. He has a boat that has a nice little Johnson motor on it, and I was sitting there just taking canned pictures and taking video and enjoying it. It was like 5:45 in the morning. They have crew practice started at 5, I want to say. And my daughter thought one term of that was just quite enough. And so she went out for rugby after that and played varsity rugby down there for the rest of her time at U of O. Rugby is a different sport. If any of you have children that want to play rugby, you need to know that the #1 rule in the rugby book, in the book of rules, is the home team will supply beer for the visiting team after every game. That is the #1 rule of rugby. That's the honest to God truth. And it was a lot more fun going to rugby matches than it was sitting out in that cold lake outside of Eugene. And so, yeah, she enjoyed rugby a lot more. How do we make water? That's what this is going to be all about. Making urine is really pretty cool, because what we do when we make urine is we put all the stuff in it that we want to get rid of. We save all the stuff that we want to save. When we need to get rid of extra water, we pee more. When we don't need to get rid of extra water, we hang on to it. And our kidney is amazing, because none of you have ever thought about, oh, gee, I need to get rid of some more urine. I've been drinking too much water here lately. It just automatically happens, doesn't it? And it's almost a thoughtless kind of thing, and I find it amazing. Micturition is an A&P word that you need to know. Micturition means the act of urinating. Thank you. This is a statue from Italy of a guy micturating. Here's a question for you. What's normal urine output? Oh, no, I'm not going to ask you, because you probably read on the paper.
No.
What's normal urine output?
I don't know.
Tamara. Cameron, you know you got a hole in your knee? Oh, God.
You like
Got one in
my
the other
kids.
pants, too. Yeah. You actually paid money for those, didn't you? And they came with holes in them, right? Yeah.
I mean, it's just a guess, but wouldn't it all be dependent on the person?
Oh, sure it is. I'm just asking for like an average daily, regular day.
After a year or before?
Huh?
After a year or before?
So that's the point.
Yeah, Friday night
It
and
is
Tuesday
quite
night
variable,
is-
but most of us have never even really thought about it, have we? You go to the bathroom, you pee a quart or whatever, you don't know how much because you never measure it really or pay attention to it, but yeah, when you're in the hospital, they're going to really pay attention to it. Yes, ma'am?
We always do that in the hospital,
Yeah, you do. Why?
because we have to know how much urine that
Input,
a
output.
patient is urinating, because it can affect the kidney function. So if they're not having any output, then we have to do a catheter.
So it's pretty important to know that they're making some urine,
Yes.
you're saying. Yeah, that's true.
In the last week.
We also, I think we in medicine are just really kind of obsessed with things that we can measure sometimes. I think I told you guys the story back when we were in digestive about the guy who came in with the book that had 2 years of his bowel movements described in color and size and length and everything else. Well, that came because every day when he was in the hospital, we would go around and say, well, have your bowels moved today, Mr. Jones? As soon as your bowels move, you can go home. Well, that's because we had taken a piece of his colon out, put the 2 ends back together, and it's kind of nice to know that things are getting through there where you sewed it back together before they go home. So, but patients don't figure that out. They don't really, they think, well, it must be really important. They ask me all these questions about my stool, so I better keep track of it, and so they do. Well, anyway, we have a wonderful monitor, probably the best monitor in all the world, called a Foley catheter, named after Dr. Foley, I believe. And the way it works is it's about this long, and it works for men and women. And this is the opening through it, goes down this way, and the urine enters in these little side holes down here at the end. And then when you put it in, you put it in all the way to the hub, as far as you can push it in. That way you know that the end is in the bladder. And then you put a syringe onto this little side port, which is where the balloon port is. And they'll say 5 cc's or 10 cc's. And so you put 5 cc's or 10 cc's in through this here, and it goes down, and there's a little tiny tube runs through the middle of this thing, fills up this balloon so it looks like that. And then you disconnect it over here, and this is a locking mechanism. So once you take the syringe out, it locks it shut, and it leaves, and the balloon stays inflated so that it cannot come out of the bladder. And it just sits there. They can stay there for 2 weeks. You don't really like to leave them in that long. They tend to get infected. But nonetheless, what they do is they tell you how much urine Mr. Jones or Mrs. Jones is making. And that's more important than anything else that you can ever monitor on the patient. You can monitor their FiO2, you can measure their PCO2, you can measure their heart rate, their blood pressure, you can measure everything in the world. But nothing is better for knowing whether that patient is doing okay than a Foley catheter and noticing that they're putting out 30 to 50, 60 cc's an hour of urine, okay? Because that tells you their heart's working fine, their lungs are working fine, their blood pressure's okay, they've got enough blood flowing to their kidney to make urine. Everything is really pretty cool if they're making a normal amount of urine. This is a little thing you hook up to it. It fills up 1, it fills up 2, fills up 3, and then every hour, if you're making a lot of urine, you dump it, and it dumps into the big bag, and then you measure how much they make in a full 24 hours. A lot of you have used those, right? I used to write this order in the chart all the time because I was trying to live somewhat normal life, although you can't do it when you got folks in the hospital. It said, it was an order for the nurses, call if the urine output is less than 100 cc's Q4 hours. And what that meant was that they were supposed to measure the urine output every 4 hours, and if it was less than 100, they had to call me. And if they called me, I was going to say stupid things like, well, how does the patient look? And what's his blood pressure? And what's his pulse? And, you know, that kind of stuff. So don't ever call the doctor in the middle of the night and not know the vital signs. I mean, it just makes sense. Because I'd be on the phone laying in bed and I just want to crawl through the phone line and grab them by the neck and say, you just woke me up.
Do your job before you wake me up?
Do your job, yeah, that's right. Anyway, now this number that I put up here, 100 cc's Q4 hours, is really only about half of what urine output should be for an average sized adult. It should be about 200 cc's every 4 hours. Well, if it's 200 cc's every 4 hours, let's see, 4 hours goes into 24/6, so that would be 1,200 cc's of urine in 24 hours. That's really a normal number, okay? There's a couple of numbers that are better than that I'm going to show you later on, but just know that we all make over a quart of urine a day. 1,200 cc's would be a nice round number for everybody in the room here. The urinary system is a very simple system. It's not like the digestive system that had about 35 organs. This one only has 4, and really only one of them counts for much. That's the kidneys. The kidneys are sitting back here in the back. They're shaped like kidney beans. That's how kidney beans got their name, by the way. They live in the retroperitoneum. They're behind the belly. They have a big, huge artery that goes to them called the renal artery that comes right off of the aorta. They have a great big vein that comes back and goes right into the vena cava called the renal vein. And indeed, about 25 or 30% of all your blood with every heartbeat goes to your kidneys. We pump a huge amount of blood through our kidneys to process it and take out the bad stuff and filter it and keep the good stuff. Once the urine is made here in the kidney, and that's what we'll be talking about for the next 2 or 3 days, is how we make that urine. Then it gets transported down these little tubes here called the ureters. The ureters are also retroperitoneal, and they go down here to the bladder. The urinary bladder fills up, and then we urinate it out, and it goes out through the final organ, which is called the urethra. They both carry, in both male and females, the urethra carries the urine to the outside, but in the men, the urethra is much more complicated because it also carries semen, and that travels out the urethra in sex. Daisy, how old are you?
21.
Oh, okay. Anybody in here 15 or 16? How old are you?
12.
Yeah. Well, I had this one girl in my class from in 233 from about this point forward, and every time I would say something like urethra or vagina or urine or semen, and we're going to talk about a lot of stuff. We're doing the birds and the bees the rest of this class, believe me. That girl would turn as bright red as your thing around your neck there. She could not bring herself to ask a question or say any of those words. They were not included in her family's lexicon, I guess. So
That mod was never downloaded?
huh?
That mod was never downloaded?
No. Anyway, so if things I say really bother you, I'm sorry, but I just try to talk about it like I talked about all these other silly organ systems that we've dealt with and learned so much about, right?
Right.
Absolutely. All right. So what does the urinary system do for you? Well, it adjusts your blood volume. In other words, if you've got 11 pints of blood circulating around in your body and that's too much, your kidneys will figure that out and they will get rid of extra fluid and you'll urinate it out. We have 2 hormones that help us with this. One of them is called erythropoietin, which I'm sure I've talked to you about, but erythropoietin is also known as EPO, and EPO is the drug that got Lance Armstrong into trouble. And the reason, and of course it got all 150 riders in the Tour de France were taking it, not just him. But nonetheless, that's the one they got him caught on. And everybody remember what EPOs, what does it do?
It generates new red blood cells.
It makes your body make more red cells. So if you have a bleed, for example, broke your arm or leg and you lost 2 or 3 units of blood, your body's going to start releasing EPO, and EPO is going to stimulate your bone marrow to make more blood cells. Okay? Now, if you're a bicycle rider and you want to be able to ride up Mont Blanc at the end of the day, like those guys do, you take EPO, and it takes your hematocrit. You remember hematocrit? What's a hematocrit? Huh?
Is it the percentage of all things in the blood that's not plasma?
Right. It's the percentage of formed elements in the blood, which is mostly all 99.9% red cells, right? So you can run my hematocrit is 45. That's pretty normal. You can run it up to 54, 55 by taking some EPO. The trouble with that, I mean, the good thing is you can carry more oxygen, so therefore at the end of the day, when you're dead tired and you've been riding your damn bicycle for 8 hours, but you still got this mountain to climb, you can do it. On the other hand, for a normal person to take EPO, it would build their blood count up, and eventually your blood gets kind of sluggish, and then it starts to kind of clot, and that's a real problem, so you don't want to do that. But for those guys who are superhumans anyway, that's what they do. Yeah.
Just out of curiosity, were they blood doping as well?
Yeah.
Okay.
They were donating their own blood, putting it in a refrigerator. Draw 2 or 3 units off of themselves over 2 weeks, and then the night before the race, they give themselves all the blood back in. It's their own blood, but that'll also run their hematocrit up pretty high. So that's what blood doping is, if you haven't heard that word before. All right, so one of the 5 things we do with our kidneys is we regulate our blood volume. We also regulate the plasma ions. In other words, we're going to be talking a lot about sodium, potassium, chloride, calcium. We're also going to be talking about bicarb and acid, H+, right? And bicarbonate, which is the primary basic alkaline ion, and so forth. So our kidneys can regulate all that, and our kidneys do. They just have a sense for whether we need to hang on to extra sodium or pee more sodium out, and that's what happens. It clearly helps stabilize our pH. Our kidneys can both hold on to acid and they can get rid of acid as needed. Conserves valuable nutrients. We would not want to be peeing out sugar, okay? Now, sometimes we pee out sugar, but that is a bad deal for our body. Why? Because we had to eat that food, we had to go kill that tiger to have something to eat. We ate it, we processed it, we digested it, we turned it into sugar or into glycogen, and the last thing in the world we want to do is just be pissing it away, right? Literally. So the kidney has a wonderful way. If it sees sugar in the urine, it pulls it back in as the blood goes through the kidney. If it sees proteins in the urine, it pulls it back in. Lots of good things our kidney can hold on to for us that we don't want to give up. It also assists the liver in detoxifying some of our poisons. Some of our poisons are almost all cleared through our urine. And that's the end of those 5.
Hal,
Yeah.
and does that mean then that pee isn't sterile? Because like you always hear, oh, pee's sterile, you can drink it.
Pee is always sterile unless you have a urinary tract infection, which is a sickness and a
So
problem.
even if it's clearing away poisons, like detoxifying.
Well, I wouldn't drink it if that's what you're asking, but it's still sterile. Yeah, it doesn't have it. Sterile means no bacteria.
Okay.
You don't, it's salty, you wouldn't want to drink it when
Yeah, but like in survival
Well, we'll talk about that
situations, they tell
later.
you like you can defilter your
Bear
pee and
Bear
everything.
Grylls drinks
Yeah, Bear
urine out of
Grylls does
snake.
that.
That was the grossest thing I've ever seen.
Oh.
in my
All
life.
right,
Bear Grylls-
we're not going to try to gross each other out here. We're just going to
But
let's keep to the slides here a little bit. So the kidneys are, both are back here in your back. The left one is a little bit higher. Why do you figure the left one's a little bit higher? Because you got something over here on the right called the liver that's kind of pushing it down on the right. Not a, that's an insignificant fact, but just so you know. The superior surface of the kidney has the supraadrenal or the adrenal gland living on it. What holds the kidney in place? Mostly it's just peritoneum and connective tissues that are back there. There's not any fancy rigging that holds the kidney in place. Back in the 50s and 60s, surgeons who really wanted to operate on people would find a person that had one kidney that was lower than they thought it ought to be, and they would operate on them. They called it ptosis of the kidney. It was dropped down, and they would operate on them, pull it back up, and sew it in place. Total waste of time and effort, but that's the way knowledge gets increased, I guess, eventually. So here they are, back here in the back of your abdomen on either side of the vertebral column. This is looking at it from the back, and they're really well protected by the lower ribs. Remember those floating ribs back there, the number 10, 11, and 12, I think, that aren't connected to much of anything. If you take a slice through the abdomen and look for the kidneys and where they live kind of like this, so that here's the vertebrae. It kind of divides the abdomen almost side to side, but doesn't really. Here's a kidney on one side. Notice it's kind of laying back in that concavity. Here's the spleen. This is the left side over here. Spleen, in front of that's the pancreas. Here's the pancreas. There's the stomach. Here's the aorta, vena cava, back there in the back. We will dissect our cats and look at all these parts on one of these days, but we usually kind of put that off a little bit yet. Yes?
When it comes to the cats, since they were starting to get a little funky and moldy, are we going to have new cats, or are you just going to keep working?
I don't know,
on the
we'll see.
disgusting ones?
We'll see. Yeah, we do have some kind of rotten ones. I'll talk to Melissa about that. Well, you guys can talk to Melissa about that too. So anyway, here's just another view from the front. Vena cava, right renal vein is nice and short. The left renal vein is a good bit longer because it has to cross over the aorta, you see, to get to the left kidney. Here's those two ureters coming down to the back side of the bladder. Remember the testicular artery and the ovarian artery. We call them the gonadal arteries at one time. That's kind of the non-politically correct, non-sexual term. Gonadal works for both women and men. But the point that this picture shows really nicely is that the gonadal blood vessels, illustrated right here and right here, come off really high. They come off way high off of your aorta. You would expect them to come off really low, wouldn't you? Because that's where your ovaries and testicles live. They live way down there low. But notice that their blood supply comes off really high. And the reason for that is that testicles, when they're formed, we'll talk about this next chapter, they form way up high and then they migrate down and work their way out into the scrotum. Some kids have what's called an undescended testicle that didn't make it all the way down there, and that's a problem we'll talk about. Ovaries also start up here high and migrate quite a bit down as well. Isn't that just a beautiful picture? Remember the three unpaired arteries of the aorta that come off the middle? The first one is the celiac trunk up here. Second one is the superior mesenteric artery, SMA. And the final one is the IMA right here. So those are the three unpaired. In other words, there are not two of them. There's just one that can come off the front of the aorta down there. The hilum of the kidney is the place where all the stuff goes into the kidney, the arteries, the veins, nerves, and it's also where the ureter comes out. This is the ureter heading down to the bladder. And so this little circle, I think here is what you'd call the renal pelvis and the hilum right there. But just remember, there's not only the ureter coming out, there's also an artery going in and a vein coming out. Probably some little nerves in there as well. This is kind of the organization of the kidney. We have wonderful models, but we will also give you kidneys to cut in half and look at. They're really nice, by the way. I think they're from cows or goats or something. They're pretty good size, though. And so these are the parts of the kidney that you need to take a look at, and we will be talking about these parts for the next 3 days. But the kidneys are formed of a series of pyramids. These are these triangulated things here called pyramids. And inside of those is what's called the renal medulla. Medulla, like almost every organ in our body, has a medulla in the middle, has a cortex around the outside, right? Same here. So here's the renal cortex, is all this whitish stuff around the outside here. The medulla is the pink triangles, which actually are more like little pyramids. In this slice, they look like triangles, but they're actually more of a pyramid when you look at them in real life. The urine actually comes out at the tips of these pyramids right here. That's where the urine actually is formed and dumps into the minor calyces. This is a minor calyx, that collecting area right there. 2 minor calyxes come together to form a major calyx, and the major calyces come together to form the renal pelvis. This is all called the renal pelvis right here. And then the renal pelvis turns on into the ureter as it goes on downstream. Notice that there's some fat in here. This is kind of interesting because this fat that you see right here is called adipose tissue in the renal sinus. And that's here and here and here and here. That fat is not in the kidney at all. It's really not in the kidney. It's just kind of working its way in around these structures that are going in there. So when you have your own kidney, you look at that and identify that. But just know that that fat that surrounds these calyces like that and works its way all the way well up into the kidney is not really in the kidney. That makes sense? You'll see it in real life later. There's a bunch of blood vessels here we're going to talk about. These areas in between the pyramids are called the renal columns, where a lot of blood vessels run through. I think that's enough. A nephron. Let's talk about nephrons for a minute. The kidney is made up of jillions, hundreds of thousands of nephrons. And nephrons are very long, and they're very convoluted, and they're very complicated. And we're going to break them down and explain them to you and show you how they work. Remember that they are microscopic. You can't really make them out grossly, but because there's so many of them and they're all going in the same direction, kind of, in a lot of places, then they sort of make more sense. But the nephrons are where urine production begins, and we'll come back to that very shortly. The blood supply, like I said, takes a large percentage of 20-25% of the total cardiac output, which means that you have 1,200 milliliters of blood flowing into your kidneys every minute. Every minute you're putting 1.5 liters, a quart plus, into your kidneys. Now remember, you're only going to make 1,200 cc's of urine a day. So you're putting in that much fluid into the kidneys every minute, and out of that it's going to come up with only 1 minute's worth of volume, same amount of volume as the blood flow. That make sense? Mm-hmm. Okay. So 1,200 milliliters of blood flows through the kidneys. It gets all of its blood through the renal artery. We do have sympathetic innervation. Do we have parasympathetic innervation? I don't think so. I don't really think we do. But when we're in fight or flight, when the tiger walks in the room and we're preparing to either fight him or run away from him, and our sympathetic system kicks in and we get all that adrenaline released and all that good stuff, what happens to our kidneys?
Stop producing.
They don't get any blood all of a sudden. They get incredibly tiny amounts of blood sent to them. So we go from 1,200 cc's a minute down to probably 150 cc's a minute, just barely enough to keep them alive. Because we can wait on making urine. We can wait till we've killed the tiger or we've run away from him and not make any pee. And I think I've told you before that when I used to run marathons, when you run a marathon, everybody has to pee right at the beginning of the race. Starting gun's getting ready to go off, and the lines at the toilets are really long. The gun sounds, and the next toilet you'll probably find on the trail is about 14 miles, and there'll be no line. Nobody will stop. Because, yeah, they've run 14 miles, but they haven't made any urine. Their kidneys are hanging on to every drop of that fluid so they can keep circulating around and making your muscles work and making your heart work and so forth. But there are nerves that go to the kidneys. The way they really work is they cause the renal arteries, the big blood vessel carrying blood into the kidney, to just clamp down. It clamps down from sympathetic innervation. Because of that, there's hardly any blood flowing to the nephrons, and we just kind of quit making urine when we're in fight or flight. The other thing that happens is that when we go into sympathetic innervation and have stresses, we also start releasing a bunch of renin, R-E-N-I-N, renin if you're from the south. But these also cause your body to just hold on to salt and hold on to water. So even if you had blood flowing through your kidney, you would be reabsorbing almost everything and making very little urine. And I must say, you know, if you run 26 miles and that's a marathon, at the end of it, you can kind of take it or leave it whether you go to the toilet, because you've probably only made about 50 cc's in 3 hours. You just don't make any. Your body's holding on to it. Here's the blood vessels. You do need to know these because they're very important in how this all works as we go through this. So here's the renal artery and the renal vein coming in. There's a little branch off the renal artery called the suprarenal artery, which goes up here to the suprarenal gland, you know, the adrenal gland living up there. And then it splits a few times into segmental arteries. So there's the main renal artery, there's segmental arteries, and then they come on up here and then they start splitting as they go between these lobes, these lobules, these pyramids, and we call those interlobar arteries, as visualized there, there, and there. And then they come on out to the division point between the medulla, the pink area is the medulla, the cortex is the outside. When they get to that interface right there, they kind of take a right or take a left, and then they change names, and we call them the arcuate arteries and arcuate veins.